All right, guys, today we're going to be continuing with 5-2 on perpendicular and angle bisectors. Really, we're going to be focusing more on angle bisectors, but I want to show you this really quick here on perpendicular bisectors. Let's think for just a minute about building a house and putting a roof on that house. If you were to put a roof up on a house, you would not, and here's what I want to explain to you. You wouldn't just set your middle post and just kind of set it up like that, right? Because what's going to end up happening is when you go to order 10 or whatever to put on this house, you're going to have one piece that's going to be like that and one piece that's going to be really short. And so your house, when you're having a house built, especially or building it yourself, me and my wife actually built our own house. It took us about 3 years to do it as we got our money, but again, it was a good experience. And one of the things you're going to understand when you build a house or have a house built is that you want everything to be square and plumb. That's two words that's going to become very familiar to you when you build a house. What that means is that you want this upright beam to be straight up and down, and you actually want it to be. Now think about this. Carpenters say it all the time. They say, we've got to make sure this is square. Well, think about if there's a square right here, then that really means to us geometrically that that's a 90-degree angle and that these two lines are perpendicular. Okay, that's what that line means or what that box means. And so now when I have my roof on my house, it's going to be the same length both ways. It's not going to be two different lengths. Okay, so that's really what a perpendicular bisector is all about. I said this once before, but geometry really is really common horse sense. If you've got common horse sense, then you can understand what geometry is really about. It uses some fancy words, but you know what? We can get past that too. So it talks about two theorems here. It says there's a perpendicular bisector theorem. It says if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of that segment. So here's basically what that means. Okay, if you've got a line here, and you notice that this is a midpoint, and that these two are congruent. It says if you go up here to a certain point on this, and this is perpendicular, this is a 90-degree angle, if you go up to a certain point and you draw a line back to those 2 points, then guess what? These are going to be the same, which makes perfect sense. I mean, if these two are the same, then those two have to be the same because these are going to be the same angle, right? Well, the converse of the perpendicular bisector theorem is basically just the opposite of it. It says, okay, if these two are equal, and there's a 90-degree angle right there, it's a perpendicular bisector, then guess what? Then these two lines right here, these two segments have to be equal. So again, just kind of looking at an example of a problem, and these, I know you're going to see that these are really easy, and so that's why we're not spending as much time on them. If you look here, I've got two lines that are, two segments that are congruent. If this is 8, what's this going to be? Well, it's also going to be 8. I mean, again, that's about as simple as it gets. And so the same thing is true here. You notice I've got the perpendicular bisector here. I've got a 90-degree angle, and I have two congruent segments. If that's the case, then I know that these two segments also have to be congruent. So what do we do to congruent segments? We set them equal to each other. So here you just do x plus 6 equals 2x. I could subtract this x from both sides, and all of a sudden I have x equals 6, and I'm finished. Again, these are really simple. That's all you would have to do in all these is just set them equal to each other. So there's not really a whole lot of reason to go through this particular part. What I want to focus on is on angle bisectors. All right, so let's look at the next page of this particular little handout here that kind of is a good baseline for our notes. And it talks about angle bisectors. So it says there's two useful theorems to remember about angle bisectors, and it's very similar to what we looked at just a few minutes ago on the other one. It says if a point is on the bisector of an angle, then the point is equidistant from the sides of the angle. Okay, so if you bisect an angle in half and you draw lines from its rays to a single point on a bisector, like this single point on this bisector here, then it's saying that value is going to be the same. If it is truly a bisector, in other words, if this angle right here is 15 degrees and this angle right here is 15 degrees, then if you come out here and you draw a point, okay, and you notice a little 90-degree box here as well, if you draw a point out here, then that means these two are going to be the same as well, okay? And again, it goes through the converse. So again, basically just to sum this up and not spend a whole lot of time on it, if you draw lines from both rays and they're equal, okay, then the point where they intersect is the angle bisector, okay? So if these two are equal, and again, you've got these 90-degree boxes here, they're perpendicular off of this ray right here, then that means that these two would also have to be the same. They have to be the same angle, okay? So let's see how that kind of works out in an actual, some actual problems, and I think it'll make a whole lot more sense. So let's move on to your practice now. And again, we're going to work through about 4 or 5 problems just to kind of make sure you've got the idea of what we're doing here. So 5-2 angle bisectors. It says each figure shows a triangle with one of its angle bisectors. So it's telling you here in the instructions why it's so important to read instructions. It's telling you here in the instructions that this is an angle bisector. In other words, angle 1 has to be the same as angle 2, which actually answers this first question for us quite nicely. It tells us that the measure of angle 2 is 26 degrees. Okay, this angle right here is 26 degrees. Well, if that angle is 26 degrees and this is an angle bisector, now think about what you do when you bisect something, right? You cut it in half. So if that's really the case, then what is the measure of angle 1? Well, the measure of angle 1, quite simply, is just 26. It also has to be 26 as well. If this line is cutting this angle in half, and this half is 26, then the other half also has to be 26, okay? The key here is to make sure that you understand what it's looking for. Is it looking for a part, or is it looking for a whole? You remember we said that before a whole lot when we were talking about the chapter 1. We're talking about segments and angles, all kinds of other things. We had to ask this question a lot, part or whole, all right? So that brings me to number 2. Notice it says the measure of QSR is 80. Now let's think about what QSR really is. Is QSR a part or is it a whole? Well, QSR is actually the whole angle, okay? So it's telling me that the whole angle is 80 degrees. In other words, this whole angle is 80. But now it's asking me to find the measure of angle 1. Well, that means I'm looking for this part right here. I'm not looking for the whole. I already know the whole. The whole has to be 80. How am I going to find the measure of angle 1? Well, remember our instruction says that each figure shows a triangle with one of its angle bisectors. That means that if this is a bisector right here and the whole thing is 80, then this particular part has to be what? It has to be half as big as that, right? Because a bisector bisects something directly in half. So 1/2 of 80 actually equals 40 degrees. So this would be 40 degrees. All right, pretty simple so far. Now you know we're going to take it up a notch. So let's look at number 7. I'm going to zoom in just a little bit so we've got a little bit bigger screen to work with. So it tells me the measure of angle 1 equals 3x minus 9. Now here's what I'm going to do, and it's going to be very difficult for you doing this electronically, and I apologize. I wish so bad that we were in person because this would be so much easier for you and for me. But the measure of angle 1, it says, is 3x minus 9. So what I'm going to do here is I'm actually going to put 3x minus 9 in there. That way I know that that angle right there is 3x minus 9. Now it also tells me that the measure of angle 2 is 2x plus 1. So I'm going to go ahead and write that here, 2x plus 1. So now I know that these two angles are these values, right? But it's asking me to find x. Well, how in the world am I going to find x? Well, again, if this is truly an angle bisector, which is what my instructions tell me, then I know that angle 1, I'm going to write this as a matter of fact, angle 1 has to equal angle 2 if it is a bisector, right? So if that's the case, then I'm going to take angle 1, which is 3x minus 9, and I'm going to set it equal to 2x plus 1. Okay? Now, let's go ahead and work this out. We're going to subtract 2x from both sides. I'm going to do this quickly. So it leaves me with x minus 9 equals 1. And then I have to add the 9 to both sides. So that gives me x equals 10. And that's really all this particular problem is looking for, is just the value of x. So that's all I need to do, okay? Let's look at a couple more problems. Number 9. Here says the measure of angle 2 is 3x minus 8. So right here, I'm just going to put a little arrow to kind of indicate what's going on here. 3x minus 8 is that angle right there. Now pay careful attention to what's really said next. What it says next is the measure of QSR equals 3x plus 11. Now what is QSR? QSR is not the part, but it's the whole. How in the world am I going to figure this out? So that means this whole big angle right here is 3x plus 11, but this little part is 3x minus 8, but all I'm really concerned about is I got to figure out what x is. Well, remember what we said. We said that if this is truly a bisector, that angle 2 and angle 1 have to be the same. That means that angle 1 also has to be 3x minus 8. Now, I've got two different ways I could really look at this, okay? And I guess I'm going to take the path of least resistance here. So what I'm really saying is if angle 1 is 3x minus 8 and angle 2 is 3x, also 3x minus 8, if I add those two angles together, it should equal the whole, right? Which we know the whole it's already telling us is 3x plus 11. So here's what we have to do in this situation. I have to take, so I'm going to write this out like this, and then we'll solve it. Then what we're saying is angle 1 plus angle 2 has to equal the whole, right? So that's exactly what I'm going to do. I'm going to take 3x minus 8, which is angle 1, plus 3x minus 8 equals 3x plus 11. Okay, so now I've just got to collect some like terms and finish solving this out. So 3x plus 3x equals 6x. Negative 8 plus negative 8 equals negative 16. That equals 3x plus 11. Now at this point I can go ahead and finish solving. So I'm going to subtract 3x from both sides. In order to speed this up a little bit, watch this. I'm going to go ahead and add the 16 to both sides as well. So 6x minus 3x equals 3x. These go away. Over here, this goes away, and I've got 11 plus 16, which is 27. So x equals 9. And that would be our answer for number 9, because that's all it's asking for. It's asking me to find x. Last but certainly not least, we have number 13. In number 13, it tells us that the measure of angle 2 is 15x. So I'm going to go ahead and write 15x right there. And it tells me the measure of angle 1 is 16x minus 2. So 16x minus 2. Now, what do I do with those two quantities? Well, first, let's look. It's telling me to find HFG. So HFG is not just a part, but it's actually the whole thing, okay? Don't get confused that you're still talking about angle bisectors, which means that this somehow, some way has to equal this, okay? So remember, angle 1 has to equal angle 2 somehow, some way. So we're going to do 16x minus 2 equals 15x. I can go ahead and subtract 16x from both sides. That's going to give me negative 2 equals negative x. If I get rid of this negative 1 that's right here, then I'm going to end up with x equals 2. Now don't get confused, I'm not done. Okay, all I've done at this point is I've figured out what x is. X has to equal 2. But now what am I going to do with that x equals 2? I've got to substitute that back in. Well, which one of these is easiest to substitute back in for? I mean, they're both the same, right? So if I go ahead and substitute that in right here, then I'm going to get 15 times 2, which equals 30, right? So that means that this particular angle right here is 30 degrees. But again, is it asking me for just angle 2? No, it's asking me actually for HFG, which is the total. Well, if this part is 30, then what does this part also have to be? This part also has to be 30. and 30 plus 30 equals 60. So the final answer for this particular problem would be 60 degrees. HFG equals 60 degrees. All right, so hopefully this has been helpful. Again, if you need help, make sure that you ask for help. We would love to help. That's what we're here for. So hopefully, again, this video has been helpful, and have a great day.